Hi everyone, it's Sorkin. Today we're going to take a look at the connected components in graph theory and how we solve problems that are related to the connected components. Let's first take a look at the problem. The problem that we have is we are given a list of computers and their connection to other computers, and we need to find the total number of the networks within the company. So for example, in this case, we have 5 computers, and the computer 1, the input for the computer 1 is true, true, false, false. It means that it's connected to itself. It's connected to computer 2 and the computer 3. The same way 2 is connected to 1 and 3. 3 is connected to 1 and 2, and the 4 and the 5 is connected, but they are not connected to 1, 2, 3. So in this case, we have 2 networks. So how we are going to solve this problem? The way we are solving this problem, we are going over each computer in our case, and we are marking each computer that we are visiting to true. So we are creating array of Boolean with the size of our computers, and also we are maintaining one more variable, networks, which is the number of the networks that we are returning at the end. So for example, in this case, let's start with 1. So we are starting with 1, and since we haven't visited that the value is false, so we are setting that to true, and we are also increasing the number of the networks. So we are incrementing because this is our first network, right? We haven't visited that computer, so this is the first network that we have. And the next step is we are depth first searching for all computers within that network. So within the network 1. So we are starting with we are visiting 2, right? 2 is equals to false. It means that it means that we haven't visited that. We are setting the value to true. So again, we are in the same network, right? We are doing a depth first search for the starting from computer 1. So, and then next one, we are going to 3. 3 is also false, which means that we haven't visited that. Again, it's in the same network. We are setting the value to true, and now we have visited all computers in the network 1. So all the nodes are visited. So now what we do, we are going to computer 2. Computer 2 is equals to true, so which means that we have visited that computer. That's a part of the other network that we have already visited. The same is for the 3. 3 is the already visited. Its value is equals to true, so it means that a part of the other network. And now we are going to the 4. 4 is equals to false. What it means? It means that this is a new network. We haven't visited that network yet. So we are setting the value of network. We are incrementing that, and now we have 2 networks. And again, we are depth first searching for 4, starting from 4. And now we are going to 5. 5 equals to false. So we are setting that to true. And now we visited all nodes. And the last one, we are visiting 5, computer 5, and the value for that true. So we have visited all nodes now. We have visited all nodes, and now we have the value. So we have 2 networks. So we have network 1, which is computer 1, 2, 3, and we have network 2, computer 4, 5. And this is a graph in our case. Our graph has 5 nodes, and the first node is, the first component has 3 nodes, and the second component has 2 nodes. So let's revisit that again. So so if we summarize, we have 5 nodes. We have 5 computers in our network, 5 computers overall. So we can say that our graph in this case, right, or our, let's say, company has 5 computers, or let's say that in our case, if we convert that to graph, our graph has 5 nodes. Not all nodes in graph connected. That's the first one, right? So, and also we have 2 components. Component 1 has 3 nodes in this case, and the component 2 has 2 nodes. To summarize, we can say that our graph has 5 nodes, and also our graph has 2 nodes. 2 components. Component 1 has 3 nodes, and the component 2 has 2 nodes. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.